This is a VU meter emulated with Arduino UNO in Tinkercad simulator. A VU meter, or volume unit meter, is an analog or digital display device used to show the average level of an audio signal. It is commonly found on audio equipment, such as mixers, amplifiers, tape recorders, and broadcasting gear. The scale of a typical VU meter is calibrated from -20 decibel to +3 decibel. -20 decibel represents very quiet signals, close to the noise floor. 0 decibel is the reference point, considered the optimal operating audio level. At this level, the audio is strong but not distorted. +3 decibel indicates a signal slightly above the reference level. Most VU meters allow a small headroom above 0 decibel, but going higher than +3 decibel risks distortion or clipping in the system.
An I2C 16x2 LCD is connected to Arduino to show the volume units and the level information. At a particular volume control position, the peak levels of the output are shown by the LEDs. Green LEDs indicate the peak levels from -20 decibel to 0 decibel. Orange LEDs show the peak levels from 0 decibel to +3 decibel. And the red LEDs turn on if the peak level exceeds +3 decibel. These 12 LEDs are connected to pin numbers 2 to 13 of the Arduino, which are configured as outputs. A potential meter mimics the volume control, of which the wiper terminal is connected to the analog input pin A1. As you may aware, the SDA, the serial data line, and SCL, the serial clock line of the LCD, are connected to A4 and A5 respectively.
The library for the I2C is included, and in line number 6, the attributes are set to 0 into 27, 16, and 2. 3 integer variables, analog level, volume control level, and peak level are defined. In a moment, I will explain the purpose of these variables. Here, the LCD is initiated, its backlight and display are switched on.
Later, in the void loop function, each time the sketch is looped, a different random number must be generated. This random seed function makes sure to generate different seed numbers each time the sketch is executed. Then the random function used in the void loop will be shuffled to produce different genuine random numbers in each run.
As we said earlier, pin numbers from 2 to 13 are assigned as outputs, and A1 is set to input. Now, the sketch inside the void loop. The variable analog level holds the readings from the analog input A1. Since A1 is connected to the wiper of the potentiometer, the stored value will vary between 0 and 1023, depending on the wiper's position. The values ranging from 0 to 1023 are then mapped to a scale of 0 to 1200 for convenience, and stored in a variable named volume control level. Since the potentiometer functions as a volume control, this name seems appropriate. However, in a real amplifier, the peak output at a given volume knob position constantly changes depending on the original audio signal. In this case, we do not have an actual amplifier providing varying peak signals, so we must emulate them by generating random numbers.
Line 47 is responsible to producing such random values,
which can range from 0 up to the current value of volume control level, corresponding to the potentiometer's wiper position.
This portion of the code checks the momentary peak level values and displays the information on the LCD. The peak level can range from 0 to 1200.
If the value is between 0 to 600, information about safe level is displayed. If the value is between 600 to 900, information about optimal level is displayed. If the value exceeds 900, warning information about clipping is displayed.
This part of the program controls the switching on and off of the LEDs based on the value of peak level. It uses 3 loops, where the outer loop contains the second and third loops. The second loop is responsible for lighting up the LEDs, while the third loop switches them off. The outer loop runs in 12 steps, 1 for each LED. In the first step, it checks whether peak level is between 1 and 100. If so, the first LED is switched on by setting pin 2 high. In the second step, if peak level is between 101 and 200, 2 LEDs are switched on by setting pins 2 and 3 high. In the third step, if peak level is between 201 and 300, 3 LEDs are switched on by setting pins 2, 3, and 4 high. This continues until the 12th step, where peak level between 1100 and 1200 lights up all 12 LEDs by setting pins 2 through 13 high. The third loop then turns the LEDs off before the next reading of peak level. The switching off happens in reverse order. For example, if 6 LEDs are lit, LED 6 is turned off first, then LED 5, and so on until LED 1 is turned off.
Thank you for watching this demonstration. I hope you found it interesting and learned something new. If you enjoyed the video, please give it a like and share it with others who might find it useful. I'd love to hear your thoughts, so feel free to leave your questions or comments below. And if you'd like to see more science content like this, don't forget to subscribe and hit the notification bell so you won't miss future videos. Thanks again for your support, and see you in the next demonstration.